Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the structure of the atom. In the earlier sessions, we have seen different concepts from this chapter like subatomic particles and their existence, the discovery of these fundamental particles, and how these are arranged inside the atom. Means different atomic models and the relations between the atoms based upon the fundamental particles. This all we have seen. In this session, we are going to see a practice sheet related to this chapter. Okay. First, let us go through the practice sheet 1, which contains completely single correct answer type questions. First, let us see the conceptual understanding questions on this. See the first question. The cathode ray experiment was done for the first time by, say, out of those 4 scientists, J. Thomson has done this cathode ray experiment for the first time. He discovered cathode rays. The credit of discovery of cathode rays given to J. Thomson. These cathode rays were later called as electrons. So this experiment was first done by J. Thomson. The charge on an electron is, what is the charge of electron? It is 1 unit negative actually. So to say quantitatively, it is equal to minus 1.602 into 10 to the power of minus 19 coulombs. Okay, this is here 1.6 into 10 to the power of minus 19 coulombs. This is the charge of electron. Next one, the nucleus of an atom contains. What does it contain? Nucleus of an atom. Actually, in atoms there exist 3 fundamental particles. They are electrons, protons, and neutrons. Out of these, protons and neutrons are present inside the nucleus. Okay, these are also called, that's why, nucleons, isn't it? Inside the nucleus of an atom there exist protons and neutrons, whereas electrons are revolving around the nucleus in concentric circles called orbits. So inside the nucleus there will be only protons and neutrons. Next one, in an atom, valence electrons are present in. Yes, atoms contains a different number of electrons in different shells. But the electrons present in the outermost shell or outermost orbit are called valence electrons, because that outermost orbit is also called as valence shell. So the electrons present in that valence shell are called valence electrons. Okay, now the answer is outermost orbit. The orbit which is last for that atom is called outermost orbit, and the electrons present in that outermost orbit are called valence electrons. Next one, the maximum number of electrons that can be accommodated in third shell. How many electrons can be accommodated in third shell for any atom? So Bohr and Bury together, they have proposed a formula to find the number of electrons that can be accommodated in a particular shell for the atom. That is 2n square, where n represents the number of the orbit. Here, it is asked to calculate or to find the maximum number of electrons that can be accommodated in the third shell, means n is equal to 3. If we substitute n is equal to 3 in this formula, we get the maximum number of electrons that can be accommodated in it. So 2 into, so if we substitute in the place of n 3, we get it as 2 into 3 square. That is 18. So third shell can accommodate maximum of 18 electrons. Okay. Next one. In an atom, the constituent electrons, where those electrons will be, they do not move, are uniformly distributed, move around the nucleus in fixed energy levels, move around the nucleus in a random way. How do they move? Yes, electrons, they won't be constant. They'll be always moving around the nucleus. Electrons move around the nucleus in fixed energy levels. They are called orbits. So electrons will be revolving around the nucleus in the fixed orbits. So this is the correct answer. Okay. Next one. What is the number of valence electrons of aluminium? What is the atomic number of aluminium? We know as it is 13. If electronic configuration, if it is written for aluminium, we get then number of valence electrons. So its configuration will be 2, 8, 3. Means in the last shell there are 3 electrons. The number of electrons present in the last shell or valence shell is its valence electrons. So aluminum has now 3 valence electrons. Okay, the number of electrons in the valence shell for aluminum is 3. Next one, which of the following arrangements of electrons represent magnesium atom? So if we know the atomic number of magnesium, then we can write its electron configuration. What is the atomic number of magnesium? It is 12. So if we write electron configuration for 12, we get it as 2, 8, 2. Because first shell can accommodate maximum of 2 electrons and second shell can accommodate 8 electrons and the remaining electrons will be distributed into third shell. Now this is the electron configuration of magnesium 2, 8, 2. Here it is represented here. This is correct. Okay, next one. The isotopes of an element have. What are isotopes actually? The isotopes are the atoms of an element which are having same atomic number but different mass numbers. So the isotopes of an element will be having same atomic number, that means same number of protons, where it is mentioned here. The isotopes of an element have same atomic number. Next one. Alpha particles are. What are alpha particles actually? The bunch of 2 protons and 2 neutrons together considered as an alpha particle. So in this there are 2 neutrons which are having no charge, and along with the 2 neutrons there are 2 protons also which are having positive charge. So altogether an alpha particle will be having positive charge. We can say alpha particles are positively charged particles because these alpha particles are a bunch of 2 protons and 2 neutrons. Because of the presence of 2 protons, these alpha particles carry 2 units positive charge. So we can say these alpha particles are positively charged particles. Okay, next one. In an atom, the mass number of an atom is equal to the number of, to which it is equal. Mass number is defined as the sum of the protons plus neutrons of an atom is taken as its mass number. Okay, we know the protons and neutrons present inside the nucleus of an atom, and hence these all together considered as nucleons. Protons and neutrons together considered as nucleons. So mass number can be defined now. Mass number is equal to the number of nucleons of an atom. Where it is nucleons here. If it is mentioned protons plus neutrons, that is also correct. But all these together considered as nucleons. So this is also right. Okay, next one. Next question, see. Number of neutrons present in hydrogen atom. So actually, the normal hydrogen has only one proton and one electron. It has no neutrons. We can say this is the only atom among all the 118 elements. It is the only element which do not have any neutrons in its atoms. Okay, hydrogen, normal hydrogen has no neutrons, zero neutrons. Next question. If Z represents atomic number and A represents mass number, then the number of neutrons in an atom can be captured as. So, the number of neutrons can be calculated if we know mass number and atomic number of an element. Because atomic number represents number of protons of that element and mass number represents number of protons plus neutrons of that element. Okay, if you know number of protons and the sum of the protons and neutrons, if you know both of these, then how can you calculate number of neutrons? Then number of neutrons is equal to, if you subtract this atomic number from mass number, we get number of neutrons. Number of neutrons is equal to mass number minus atomic number. Where is it mentioned here? This is. So number of neutrons we get by subtracting atomic number from mass number. Okay. Next one. The number of electrons in the outermost shell in the atom of an inert element is. So for inert elements, we know for inert elements they have octet configuration. Octet configuration means having 8 electrons in the outermost shell. Those elements which are having 8 electrons in the outermost shell being more stable. They are called inert elements. They do not participate in the chemical reactions. So these elements will be having 8 electrons in their outermost shell except helium. Isn't it? I think you come to know about helium. Helium is also one of the inert elements, but it has only 2 electrons in its outermost shell, that is in the first shell. So except helium, remaining all noble gases or inert elements, they have 8 electrons in the outermost shell. So most predominant answer is here no 8, because it is single correct answer type question. So 2 is only applicable for helium. Next, which of the following is true regarding electromagnetic radiation? Let us see once first statement given about electromagnetic radiations. They do not require any medium for their propagation. Yes, electromagnetic radiations, they can travel through medium, and even without any medium also they can travel. In the vacuum or space also these can travel. They do not need any medium for their propagation. This is correct. These electromagnetic radiations consist of both electric and magnetic fields. Yes, because these electromagnetic radiations are being produced by charged particles which are revolving with the high speed. So, as these are produced from the charged particles, they possess both electric and magnetic fields. This is also correct. Next statement. All electromagnetic radiations travel with velocity of light. Yes, this is also correct. Because all the electromagnetic radiations, they travel with the same velocity, which is considered as the velocity of light. So this is equal to 3 into 10 to the power of 8 meters per second. So all the electromagnetic radiations are supposed to travel with the same velocity. So these three statements are correct. What will be correct also? This. So the next question. The value of Max Planck's constant in Celsius units. We know Planck's constant is equal to 6.625 into 10 to the power of minus 27 erg second, or 6.625 into 10 to the power of minus 34 joule second. Here it is asked to mention its value in Celsius units. So it will be equal to 6.625 into 10 to the power of minus 27. Its units will be erg second in Celsius units. Okay. Next, let us see here single correct answer type questions. See the first one among those. The atomic number of an element is 11 and its mass number is 23. Now, the correct order representing the number of electrons, protons and neutrons respectively in this atom is. So they have given here atomic number and mass number. We know atomic number for a neutral atom will be equal to number of protons as well as number of electrons. Now number of electrons we can say as 11, and even number of protons also equal to 11 because its atomic number is mentioned as 11. Now we can calculate number of neutrons by using the formula number of neutrons is equal to mass number minus atomic number. Mass number they have given as 23 and atomic number is mentioned as 11. Now what will be the number of neutrons? Equal to 12. Number of neutrons is 12. Now electrons 11, protons 11 and neutrons number is 12. Where it is mentioned 11, 11 to 12. So it is the correct answer. Got it? Now atomic number is equal to number of protons. For the neutral atoms, number of protons is also equal to number of electrons because negative and positive charges will be equal in a neutral atom. So electrons and protons number is equal to 11. And number of neutrons can be calculated by using the formula number of neutrons is equal to mass number minus atomic number. So we get it as 12. Okay, see the next one. Which of the following pairs are isotopes? What does it mean by isotopes? The atoms of an element which are having same atomic number but different mass numbers are called isotopes. See, first one, oxygen and ozone. These are not isotopes. These are called allotropes. Means are substances of the same element with the different properties. And ice and steam, both are representing the same compound but in different physical states. Nitric oxide and nitrogen dioxide. These two are the oxides of the same element nitrogen but not isotopes. If you observe hydrogen and deuterium, these two are isotopes of hydrogen. They have same atomic number but different mass numbers. So this hydrogen is represented like this with atomic number 1 and mass number also 1. Whereas deuterium is represented like this, atomic number 1 and mass number is 2 because this deuterium is existing with one neutron, whereas normal hydrogen has no neutrons. Now if you observe these two, they are having same atomic number but different mass numbers. That's why these are called isotopes. This is the correct answer. Okay. Next one. The number of electrons in an element with atomic number X and atomic mass Y. What will be the number of electrons in it? Mass number is given and atomic number also is given. We know for any element, atomic number is equal to its number of protons. For neutral atoms, number of protons is also equal to number of electrons. Now we can say atomic number for neutral atoms is equal to its number of electrons. So atomic number is mentioned as X here. So X will be the number of electrons present in it. So no need of mass number here for the calculation of electrons. Just for confusion they have given. So atomic number is equal to number of protons as well as number of electrons. See the next one. The relative atomic masses of many elements are not whole numbers. Yes, we observe for certain elements the atomic masses are being in fractions. For example, if you see hydrogen, its atomic mass is 35.5. In this way, for certain elements, atomic masses are not being whole numbers. They're being fractional numbers. Why it is being so? This is because of existence of isotopes for these elements in the considerable abundance. Because of the existence of isotopes, their atomic masses are calculated by taking the average masses of these all isotopes. We have one formula for the calculation of atomic weight or average atomic mass for those elements with considerable amounts of isotopes. So by calculating with the formula, we get certain fractional numbers for those. So the reason for that having fractional number is existence of isotopes for those elements. Okay. Next, which of the following describes an isotope with mass number 99 and contains 56 neutrons in its nucleus? See, they have mentioned here mass number. So for representing or describing an element, we need to know the symbol and atomic number and even mass number also. They mentioned already here its mass number as 99. Now if we know its atomic number, we can describe that element. But they did not give here atomic number directly. They have given mass number and the number of neutrons. If you know mass number and number of neutrons, we can calculate the number of protons so that we can say atomic number. What relation we have between these all? atomic number, mass number and number of neutrons. Number of neutrons is equal to mass number minus atomic number, isn't it? In this, mass number is given and number of neutrons also is given. Now if you calculate atomic number with this formula, from this we can say atomic number is equal to mass number minus number of neutrons. Mass number is mentioned as, what is the mass number given? 99. And the number of neutrons is given as 56. So we get the number of protons or atomic number as 43. So atomic number is 43 and mass number is 99. Where it is mentioned here, atomic number 43 and mass number 99. Technetium. Okay, this is the element with those descriptions given. Next, which of the following is not a basic particle of an element? So what are the basic particles generally for an element? First, there will be basic particles, atoms, because atoms are the fundamental particles which represents all the characteristics of an element. Even certain elements, they exist in the form of molecules also. So an atom and a molecule, both are the basic particles of an element. But an ion is not a basic particle, because an ion is formed when it participates in the chemical bonding. Until and unless it is participating in the bond formation, these ions won't exist. So we can say ions are not the basic particles of an element, whereas atoms and molecules are basic particles. Okay, so the next one. Members of which of the following have similar chemical properties? Isotopes, isobars, allotropes, both isotopes and allotropes. Generally, isotopes of an element having same atomic number, so their electron configurations will be same, so they show similar chemical properties. Even allotropes also, you don't know actually about the allotropes. Allotropes means the existence of an element in more than one physical state with the same chemical properties is called allotropy, and those physical forms are called allotropes. For example, if you see element carbon, it exists in different physical forms like diamond, graphite, coal, charcoal. These all are the different physical forms of carbon. These all contain element carbon only, similar, same element carbon. But they have physical existence in the different ways. But they do participate in the chemical reactions in the same manner. So we can say here isotopes and allotropes both will be having similar chemical properties, because in isotopes atomic number is same, say they have similar electron configurations, and in the allotropes also element is same, only the difference in physical existence. Okay, so both allotropes and isotopes both will be having similar chemical properties among them. So next one, chlorine 35 and chlorine 37 are examples of. See, what is the similarity between these two? Both are the atoms of same element chlorine, and we can observe here both are having same atomic number 17, but they have difference in their mass numbers. One it is having 35, whereas other one is having mass number 37. So like this, the atoms with the same atomic number but different mass numbers are known as isotopes. Okay, chlorine 35 and chlorine 37 are isotopes. These are examples for the isotopes. Okay, because they have same atomic number but different mass numbers. Next one, an alpha particle is. What is alpha particle? We told here. Alpha particle is a bunch of two protons and two neutrons. So it is similar to the helium nucleus, because we know helium atom is having two electrons, two protons and two neutrons. isn't it? This is the number of fundamental particle existence in helium atom. If these two neutron electrons are removed, now it remains with two protons and two neutrons in its nucleus. No electrons outside. Only helium nucleus exists now. This is similar to an alpha particle. An alpha particle is nothing but the bunch of two protons and two neutrons. That's why you say alpha particle is also represented as He2 plus ion, because after removal of two electrons from helium, it remains with two protons or two neutrons. Okay, alpha particle is similar to that of a helium nucleus. Okay, this is correct answer. Next one. Rutherford's gold foil experiment showed that most of the alpha particles passed through the gold foil without any deflection. It indicates that. What indicates here? In his observation, the major observation is in the gold foil experiment, most of the alpha particles passed through the gold foil. After striking the gold foil, they did not get any deflection. Directly they passed through the gold foil and they made scintillations on the zinc sulfide screen exact back to gold foil. So from this, he concluded that most of the space in the atom is empty. Okay, where it is mentioned, here it is. There is a lot of empty space in the atom. Only a small portion of the atom is completely covered with mass. Remaining part is being empty. Because of this empty place existing in the atom, these alpha particles pass directly through the atom without any deviation. Okay, next one. Two elements X and Y have same atomic mass, but their atomic numbers are 20 and 21 respectively. Then what are these two elements X and Y? We have a definition. The atoms or the elements with the same mass number but different atomic numbers are known as isobars. Here X and Y are having same mass number or atomic mass, but their atomic numbers are being different. That's why we can say this X and Y are isobars. Okay, X and Y are isobars. Next one. The electronic configuration of an element is 2, 8, 3. The number of valence electrons in this atom is. What is meant by valence electrons? The electrons present in the last shell of an atom are called valence electrons, because that last shell of an atom is considered as valence shell, and hence the electrons present in that valence shell are called valence electrons. See, for this element, how many electrons are there in the last shell? There are 3 electrons. Now we can say these are the valence electrons of that atom. So valence electrons for this atom are 3. Okay. Next, the wavelength of a blue light is 4000 angstroms. The frequency of this light is. How do we know the frequency of light if the wavelength is given? We know the relation between the frequency and wavelength. That is, nu is equal to c by lambda. Isn't it? They're asking to calculate frequency. They have given the wavelength lambda. If you substitute these values, and here c is a constant whose value is equal to velocity of light. Velocity of light is equal to 3 into 10 to the power of 8 meters per second. Isn't it? This is the velocity of light, c value. And the lambda value they have given as 4800 angstroms. So velocity of light is taken in the SI units. So let us convert this also into SI units. We know 1 angstrom is equal to 10 to the power of minus 10 meters. So if you multiply this with the 10 to the power of minus 10, this total value converts into meters now. So if you simplify this, what do we get? Try to calculate that now. What do we get? 3 divided by, we get it as 0.0000625. if you divide this 3 with 4800 into 10 to the power of, if you bring this 10 to the power of minus 10 to numerator, it becomes 10 to the power of 10. 10 to the power of 10 into 10 to the power of 8, it becomes 10 to the power of 18. Now if you adjust this to decimal to 6.25, then it becomes 10 to the power of 14. It is equal to 6.625 into 10 to the power of 14 second inverse, where it is here. Okay, this is the correct answer because here the decimal is now. If you bring these two before 6, it becomes 6.6 6.25 into 10 to the power of 14 per second or second inverse. Okay, this is the answer now. So in this way we can calculate the wave frequency if the wavelength is given. Sometimes they make you frequency and may ask to calculate wavelength. Then also we use the same formula, that is nu is equal to c by lambda, where nu is the frequency, c is the velocity of light, and lambda is the wavelength. Remember, all the quantity should be taken in the same system of units before doing calculation. If they are given in the other units, first they have to be converted into the same units, same system of units. Okay, next one. Calculate the energy associated with a photon of light whose frequency is 3 into 10 to the power of 15. So here frequency of the radiation is given, frequency of the light is given, asked to calculate energy. What relation we have between the energy and frequency? This relation E is equal to h nu, where E is the energy of light radiation, h is Planck's constant, nu is the frequency. So if you substitute these all values, h is a constant whose value is equal to 6.625 into 10 to the power of minus 34 joule second. Okay, and frequency they are already given here as 3 into 10 to the power of 15. We substitute this value here. Okay, these two will be getting cancelled. Now if you multiply these two, 6.625 into 3, we get it as 19.875 into, what do we get into here, minus 10 to the power of minus 34 into 10 to the power of 15. It becomes 10 to the power of minus 19. Finally units are joules, where it is 19.875 into 10 to the power of minus 19 joules. So if it is adjusted to decimal here, then it is equal to 1.98 into 10 to the power of minus 18 joules. This is the correct answer. Okay, in this way we do calculations by substituting the values. Okay, this is about the practice sheet 1. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.